So this book problem is often called the stacking problem. It's actually a fairly classic physics problem. So if I have a ledge there and I have a book or some sort of square thing, how far over the edge could I put it until it begins to tip, right? And so if this is the center of mass, right now, the center of mass, force of gravity, would not produce a net torque, so this object would not tip. So if this is L, then this would be L over 2, and as long as that's true, as long as, let's say, actually, let's call this distance x, the overhang, or d, the overhang, as long as d is less than L over 2 for one book, then this system doesn't tip because the center of mass of this system is over the area of stability, and you don't have to worry about it. Things get a little trickier, though, as we talked about when I had 2 books. Because if I have 2 books and they're stacked exactly one on top of each other, okay, there is the center of mass of that system, right? Here's the center of mass of each object. Actually, I'll do those in red and in green, right? Whereas the one in black is the center of mass of the system. Here, you could either think of that as neither of these 2 forces cause a net torque that causes the system to rotate, or the center of mass of the system, the one force of gravity acting on it, acts through the pivot and therefore doesn't cause a force in order to change. Now, notice here I'm not doing a free body diagram because our analysis here for the does it tip problem is more about where the center of mass is relative to the area of stability. Here is the entire area of stability. As long as the center of mass is over that, then I don't have to worry. So the more interesting thing occurs, though, if we displace the books relative to each other. Okay? There we go. And this is what we were drawing before. I'm just going to draw a smaller picture here. And the question is, how far over the edge, what is that new d, total distance over the edge that this system could be, or how do we maximize that? And so that's going to be the problem that we're going to talk about, right? So notice here, this object's center of mass is here, and this object's center of mass is here. Now, how do I know it's exactly there? We talked about that this book, in order to maintain balance on top of the lower book, has to have its center of mass over the, or at the point of the edge. That maximizes how far over this can go, right? But in order to keep the system center of mass at this point, then the center of mass of this object below needed to be shifted to the left a certain amount in order to make this shift over the edge. So the question is, how big is D, right? How can I maximize the total distance over the edge? Now, I know this distance here is L over 2, and I know this distance here is L, and I know this distance here is L. So I want you to think about this as a center of mass problem, which means that we need to create for ourselves an axis or an origin, and then do our center of mass problem, and we want to locate our center of mass exactly here, wherever that is, and then figure out what this distance is. And that's actually problem 22 in the textbook, which is the problem that I want you to try. Now, that's problem 22, but we're going to go on then and expand this out. If you can figure out 22, what I want you to think about then is, well, what happens if we add a third book to this? Okay, so now I have this book here, I have this book here, and I have this book here. The logic still remains that this book is going to be L over 2 over the edge of this book. Now, this problem is essentially treating this block here as the table. And so the question is about just like adding the same sort of analysis for the book underneath. And so can you then find what D is, the total overhang? And I'm going to tell you, if you can find out, well, we know that this is L over 2. If you can find out how much this is, and then find out how much this is, hopefully you'll see a mathematical pattern that will help us talk about what happens when I don't have one book, two books, three books, but 4, 5, 6, or n books. And so I'd like you to try to do this problem here, which is problem 22 in the textbook, and then give a whirl to this problem here with 3 books using that logic system. It's a center of mass problem, not a torque problem, right? And then using this, can you extrapolate this out to n books to see if you can write an expression for D as a function of n books. And then we're actually going to meet as an entire class and have a discussion about this problem where people can put forward their solutions and what the implications of those solutions are.